Good evening, class, and welcome to our performance management class. My name is Chima, and today we are continuing on the topic linear programming model. In the last class, we were able to do a linear programming model using the graphical solution. In the graphical solution, we first of all defined our variables. We called one of the, the things that we are given the variable x, that is donuts, and meat pie we called y. And we said that linear programming, the relationship is a straight line relationship. And when there are more than one unknowns or one scarce resource, we use the linear programming. Then we started to do with our objective function. The objective function is to maximize contribution C. Sometimes contribution can be called C or Z. And this is our contribution function. Then we were given constraints M1, M2, and M3, and we were given their maximum values. Then we decide to add slack variables because we said it's possible that we may not use all of them. If we don't use all of them to the max, that means something will remain called the slack variable. Now, if we use it to the max, that means our slack variable will be 0, meaning that nothing was remaining. And we now set it to be equal to, so when we are removing the inequality sign, we are adding the slack variable. Then we now set all of these to be non-negative. So it's either going to be 0 or positive figures. Then we now decide to draw the graph. We now assume that S1, S2, and S3 are 0, meaning that it's possible we utilize everything. So we draw the graph of X and Y equals to their maximum value. We plot a table of values where we have to do for Y or for X when Y is 0. Then we in turn look for Y when X is 0. We then plotted the graph. When we plotted the graph with these 2 points, we use our ruler to join them. We now found the feasible region. The feasible region is the area under this, from the origin down to this area that is bounded by the origin. Then we now tested each of these points, 0, A, B, and C, for optimality. How did we test? We look at point 0, X is 0 and Y is 0. We slot it into the contribution function to see how much it is going to contribute if we are to produce nothing. Our contribution was 0. Then we decide to test at point A. In point A, we decide not to produce X, but our Y was 60. And so we have 6,900 as our contribution. Then we get to point B, where we decide to produce only X, 60, and Y was nothing. Our contribution was 6,000. Then we went to point C. In point C, it is not easy for us to get the coordinates of X and Y. So we use a simultaneous equation. First of all, to find what point C is. We use the simultaneous equation. We found out that X is 30 and Y is 50. We now tested it by slotting 30 and 50 in X and Y respectively in the contribution function, and we got C to be the maximum contribution of 8,750. And we now said our optimal production is 30 for X, 50 for Y. The contribution was this. We decided to find our maximum profit by removing it from the product cost. Just to let you know that it is the November 2017 question number 5 we were solving, and we decided to expound the question. The question only asked to formulate the linear programming model, but we went ahead to solve. We call that one A2. We solved the linear programming model. Then we went one step ahead to look for the slack variable. And for us to look for the slack variable, we need to test the contribution. We need to test our values for X and Y in M1, M2, and M3. Anyone that gives us something that is not 0, it contains slack. So when we slot it for M1, we found out that about 740 was used. Okay, about 740 hours was used, remaining 60 hours. 60 hours was the slack, unused hours. For S2, we found out that there was no slack variable, everything was utilized, and M3, everything was utilized. It is not surprising that M2 and M3 had no slack variable, because look at this point C. It was produced as a result of intersection of M2 and M3. And if you look at this line, this is the M3 line, this is M2 line. So because they meet at this point C, it became the optimal. We used everything without the slack value. And this red line is the M1. So this side here, this length is the 60. That is the slack variable. All right, so we then decide to go another step further to find the shadow cost. How do we find the shadow cost? We look at the bounding constraint M2 and M3 and we take them in turns. When M2 was chosen, we just add 1 to the quantity, and we are saying that if we can just increase this by just 1 unit extra, how much contribution are we going to get? We found out that we had an extra contribution of 7 naira 70 kobo. Then we decided to do for M3, we just added 1 here and we solved simultaneously, and we found out that our extra contribution was 5.73. Then we now had the summary. The summary we had here was graphical method was used, table of values were found using 2 points X and Y. One of the constraints does not enter the optimal solution, which is M1, and it has a slack variable S1, which is 60. The optimal solution was gotten when we tested the points in the feasible region, that is in point C. And point C is bound by M2 and M3, which we got their values using simultaneous equation. And we look for the shadow price by testing these optimal lines by just adding 1 value to the total, taking it turns. And we found out that the shadow price gave the highest contribution per extra scarce resource, which shows that that particular constraint should be concentrated on. So I want us to now look at this reference here, this optimal solution. We are going to be comparing our optimal solution gotten from the graphical method with that will be obtained from the simplex method. So now we have the simplex method. Now, in the simplex method, what do we need to do? First of all, you need to formulate the matrix or the matrix. And how do you do that? You first of all look at the objective function here. The objective function. So look at the objective function here. Objective function. And we say it is C equals to 100x plus 115y. We can remember that was what we have. We know that x and y is donut and meat pie. Then the next thing I'll be looking at, we'll be drawing the same, we'll be looking at this same thing here. This is the same thing we want to do. So we have 8x, 10y, s1, 800. 8x, 10y. So we have constraint. We have m1, 8x plus 10y. Then we have plus s1. There's something I'm going to do here. I'll be giving a lot of space. I'll say equal to 800. Now the question is, why am I giving this space? Why? Okay, we'll see that in a moment. Then we have M2. In M2, we have 10x, 6y, S2, 600. 10x, 6y, 600. We have 10x plus 6y. Now we say plus S2 equal to 600. Now, can you notice something here? All the things that are x, all the x values are all in one line. All the y values are in one line. S1 is in one line. So I can put S2 under it. So S2 will be on its own line. So you can see why I'm giving a space, because I know for M3, I will be having S3. So you now get the gist. 4x, 12y, 720. 4x plus 12y. Now come here, plus S3 equal to 720. All right, so for it to make it standard form, you must make everything here, everything must have x, y. There must be S1 all through, S2 all through, and S3 all through. Now, in the case of this one, it has only S1. S2 is not existing. But in standard form, you must put S2. So the coefficient of S2 must be 0. So this means that S2 was not there before. That's why we have 0 S2. Now this S1 standing alone is as good as saying 1 S1. Okay? So the same thing here, there was no S3, so we say 0 S3. In this case here, we have 0 S1, of course there's S2, and there is 0 S3. In this case here, there is 0 S1, 0 S2, and that's it. Now, the contribution function will also be expressed in that way. Will also be expressed in that way. So you will rewrite the C here. Now the C will not be the last thing here. C. So what will happen now is you bring all of these from this side that they are, this right hand side, you bring them to the left hand side. So you will say if there is 100x, it will become minus 100x, right? Now this is 115y to become minus 115y. Then there was no s, no y, no, there was no s1, s2, s3, so simply put 0 s1, 0 s2, 0 s3. If you like, because they have been expressed in minus before here, you can decide to put minus all through. Like you can put minus all through, so that you know that everything here has minus sign, and here will be equal to 0. So because you have moved everything here down from the right hand side to the left hand side, 0 will be here. So that's just it. Now we know that our non-negative constraint, we know that's non-negative. So I want you to remember all of these. Non-negative constraint, we have x, y, s1, s2, s3. We know they have to be greater or equal to 0. That was the first thing you're going to do. Then the next thing is to put them in a table. Now this is how the table is going to be done. That's why we arrange them in standard form. So what we do here is, this is our initial table. We call this one initial table. Initial table. Okay. So how do we create the initial table? We have our basic variable, basic variable. Then we have our x. We have our y. We have s1, s2, s3. Then we have our solution quantity. Right? So we don't know what is the basic variable here, but what we'll do here is we will put all of these values. So for x, we have 8, 10, 4, and minus 100. 8, 10, 4, minus 100. So we have 8, 10, 4, and minus 100. Now under y, we have 10, 6, 12, minus 115. 10, 6, 12, minus 115. We have 10, 6, 12, minus 115. Then we have S1, that's invisible one here, that's 1, 0, 0, 0. 1, 0, 0, 0. In S2, 0, 1, 0, 0. 0, 1, 0, 0. And in S3, we have 0, 0, 1, 0. 0, 0, 1, 0. Then of course, 800, 600, 720. So this is 800, 600, 720, and here is 0. So now, okay, so that's it. We have almost formed the basic variable. We have almost formed the basic variable. So I need to rewrite this so that it will not clean it off. This is 800. All right. So what is a basic variable? Here will always be C because this is where our contribution is. So, but what do we have here, here, and here? Now, if you look at this, and our initial table, at our initial table, that is the origin. In our graph, it is that point 0 where x is 0 and y is 0. So that is what our original table is, our initial table. We are looking at it that assuming that we have not done anything, this is the initial table we are setting, we are just setting up, we have not produced. What will our basic variable be? It means that if x is 0, that means 8 times x will give you 8 times 0, that's 0. Y is also 0. 10 times y is 10 times 0 is 0. So we have 0 plus 0. There is S1. 1 times S1 is S1. 0 times S2 is 0. 0 times S3 is 0. So it means that S1 is the only surviving thing here that is not having 0, that is having 1. And so it means that S1 is going to be here. It means that what happens is that if nothing has been produced, that means our slack variable will be 800, meaning that the machine has not been used. 800. So S1 will become the slack variable. In the case of this line, second line, S2 will become the basic variable. In the case of this side, S3 will become the basic variable. Now you have set the initial table. So what do you need to do next? Now, what you should note here is as long as C is lesser than 0, there is room for improvement, or chances of optimality. So it means that anytime you see any of these lines here having zero negative, it means there is a chance that we can do something more to improve the situation. Now our objective is to turn all these negatives to either 0 or positive. Once there is no negative line here, we have achieved our aim and it is time to stop. But as long as there is a minus sign down here, we need to create another table. So there is a rule for creating the new table. First, we need to know something called the key column, or they call it the pivot column. So I will come here and say pivot column is the column that has the greatest negative value of C. So if you look at 100 and 115, 115 has the greatest negative value. So here I will call this the pivot column. So this is a pivot column. So what it means here is that this is the pivot column. Now, what does a pivot column means? It means that this basic variable y, that is a king in that column, is going to go to take its seat in the basic variable. So this y will be transposed. It's going to be transposed and it will be sitting in one of these places. We don't know who is going to displace, whom is going to chance. Is he going to tell S1, please excuse me, I want to take my seat? Or is he going to displace S2? Or is he going to displace S3? Of course, nobody will displace the C because the C is the kingmaker. But this family house of Y, the household of Y, has been chosen as the next family to produce the king or to produce the master. So, but where is he going to sit? Now, we need to look for the pivot row. The pivot row is the family that is going to give way for the pivot column to take its seat. Now, how do you get your pivot row? This is what you will do. So I will say, use another color for the pivot row. Now, pivot row is the lowest positive value that results that results when each element of the solution mix or the solution quantity is divided by corresponding value in the pivot row, in the pivot column, sorry. So what we are going to do here is we are going to do something here. This is our pivot column, right? And this is Y, right? Y is the pivot column, and we say this is 10, 6, 12, 115. 10, 6, 12, 115. So this is 10, 6, 12, 115. Because this is our basic variable, and sorry, this is our basic variable should be here, not here. Basic variable, and this should be our solution quantity. And this basic variable we have here as S1, S2, and S3. Okay, then we have basic variable solution 800, 600, 720. So this is 800, 600, 720, and 0. So this is what we have. I'm just bringing them out here. Okay, so what happens is that this is the family line. This is the family line that is next in the kingship. It means that this family of Y will take, sorry, this is S3 here, and this is our C. It means that this family line of Y will take its seat by replacing one of these. So we don't know whom it is going to replace. So we'll do the fraction here to find out whom it is going to replace. Now, note that this man is the kingmaker. This line here in C is the kingmaker. It is not involved in the tussle. So these are the contestants in the Y family. There is contestant number 10, contestant number 6, and contestant number 12. Now, how do we choose who is the winner? We simply say 800 divided by 10. What would that give me? That will give me 80. Then we have 600 divided by 6. That will give me 100. Then we have 720 divided by 12. What would that give me? Let's try. 720 divided by 12. That gives me 60. And we said the lowest positive, the lowest positive, the lowest positive is the pivot column. So it means that this family of Y will replace the family of S3. So that's what we are trying to achieve here. So this is going to be the pivot column. meaning that Y will replace S3 and the new king. Okay, so this is call here pivot. We write it down here. Pivot column. And now I'm going to decorate our king. This 12 is now the king. It is called the pivot number. Pivot number. So I will say the pivot number. So I will come here and I will make it here. The pivot number is the intersection of the pivot column and the pivot row. So 12 is the pivot number. Okay, so we have identified the king. So in the next table, which we are going to do now, the king will take his seat first. So we'll say first iteration. Iteration is simply a movement. First iteration, which is second table. Either you call it first iteration or you call it second table. We have our basic variable. Then we have x. We have y. We have s1, s2, s3, solution quantity. So we are now trying to form the next table. So we said y will replace s3. That means s1 and s2 will remain where they are. So if we know that s1 will remain where it is, s2 will remain where it is, but for s3, s3 is going, y is taking its place. And of course, we'll have our c being where it is. So that's the first thing you're going to do. Okay. Now, because this is the king, I'll call it master. So the master will take its seat first. Now, there is a rule for the master to take its seat. You see this position where this king was sitting down here? This is this 12 that was here under row column Y. In this column Y, in the new table, this position where 12 is must be 1, and everything above or below it must be 0. So in column Y, this must be 1, and everything here will be 0. Must be 0. The question is, how can we make Y to be 1 here? What we simply do is we divide everything in this row. We divide everything in this row by this pivot number. So the next, so we say master Y takes its seat first by dividing all the elements of the former pivot row by the pivot number 12. So what we have here, I'll bring this thing down here, 4, 12, 0, 1, okay, 4, 12, 0, 0, 1, 7, 20. So what it means here is, this is 4, 12, 0, 0, 1, 7, 20. Of course, this is X, this is Y, this is S1, this is S2, this is S3, this is the solution. So what we are saying here, we are going to divide this by 12, divide this by 12, divide this by 12, divide by 12, divide by 12, divide by 12. So 4 over 12 is as good as 1 over 3. Leave it as 1 over 3. 12 over 12 will give you 1. So you see we have achieved that 1 here. So we have 1 over 3. Let's put it down immediately. 1 over 3. We have 1 here. Then we have 0 over 12 will give me 0. That will give me 0. 1 over 12 will give me 1 over 12. 720 over 12 was done here. We got 60. So it is these figures we are going to take up. So put 1 before 0, 0, 1, 12, and 60. 0, 0, 1 over 12, and 60. Now, after Y has taken its seat, all the others can take their seat. Now, there is a way we must arrange them in such a way that they will follow the way that here, here, and here must be 0. So all other numbers, all other variables will now take their seats using the formula old minus new times old. I will interpret. Now, let's do them one by one now. This is for column. Okay, we want to use S1. Now, let's say S1 wants to take his seat. S1. So I will say this is S1. We want to try it for column X. So column X, we want to check what will this position here be. S1 column X. Now what is old? The old one here will be old S1 column X minus the new is master Y. The new is master Y position here. So you will now say new is master Y X here. multiplied by, what is this old? The old will be, look at where master y was before. Look at where this king here is. This is where this king here is. So since we are looking for S1, see this value here must be 10. So let's look at it here. By the time I'm working it here, we will now say this is number above or below pivot number in old table. Okay, so what it means here is your old here, the old table here is 8. So I'm taking this 8 as our old minus new in that same line of x, because we are doing x. X here is this 1 over 3 in this master row. 1 over 3, 1 over 3 times, go to the old row. Look at this pivot column. Because we are doing S1, it must be this 10. So I know it sounds confusing a bit, but just follow it religiously and you will understand. So this is going to give you 8 minus 1 times 10 is 10. 3 times 1 is 3. 10 over 3. That is what it means. So 8 over 1 is the same thing as 8 over 1 times, okay, minus 10 over 3. Okay, LCM here is 3. 1 times 3 is 3. 3 times 8 is 24. 3 into 3 is 1. 1 times 10 is 10. So we have 24 minus 10 is 14 over 3. So let's leave it that way. 14 over 3. That is what will be your value here. 14 over 3. What will be the value of y? You see, when we apply this formula, it will give us 0. So we'll come now to S1y. Our old will be in the old table. S1y is 10. S1y is 10 minus the new in the master row is 1 here. So you just say 1 times, of course, the number above pivot in S1y is 10. So you see that this particular 10 will be common for this line SY, S1. This 10 will be common in all of them. So we will not be going back and forth to be looking at it. So this is going to be 10 minus 1 times 10. That gives you 0. Then we'll go to the next one. S1, S1. What is the old S1, S1? It's 1. So this is 1. Sorry. That's 1. 1 minus, what is the S1 under the pivot row of the master row is 0. So 0, of course, we say multiplied by 10. You don't need to be going back and forth. This is going to give me 1 minus 0 times 10 is 0. 1 minus 0 is 1. So we'll come here, write our 1 here, then S1, S2, S1, S2. What is the old S1, S2? It's 0. Okay, so I'll be doing them sharp sharp. S1, S2 is 0. S1, S3 is 0. Then there is 800. Let me be doing them sharp sharp. 0, 0, 800. So this is S1, S3, S1 solution. Okay, so we have 0, 0 fast. Now, what is the corresponding value in Y? In master Y. S1 is 0, S2 is 0, 1 over 12, and 60. We have done S1. S2 is 0, 1 over 12, 60. And we're going to multiply by 10, multiply by 10, multiply by 10. So this will give us 0 minus 0 times 10 is 0. 0 minus 0 is 0. So we'll go down here, 0 here. Then we come down here, 2 again. This is 0 minus, so it's going to be 1 times 10 is 10, 12 times 1 is 12. So 0 minus 10 over 12 is the same thing as saying minus 10 over 12, which is still the same thing that if you divide by 2, it's going to give you minus 5 over 6. So you can come here and say minus 5 over 6, minus 5 over 6. Then we do the next one here. This one happens to be 800 minus 60 times 10 is 600. That will give you 200. So we put our 200 here. Okay. So we now turn our attention to S2. So we are done with S1. So these are the places we started with S1. So we start with S2. We do similarly S2X, S2Y, S2 um, S2, S1, S2, 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 S3, S2 solution. So the formula is, what is the old position of S2? I'll bring this thing down here. 10, 6, 0, 1, 0, 600. 10, 6, 0, 1, 0, 600. 10, 6. So this 10, 6, 0, 1, 0, 600. So old minus the new. What is the new? all you need to do is to bring this master y, all of these, 1 over 3, 1, 0, 0, 1 over 12, 60. So it means that you have done it here. 1, okay, we started with 1 over 3, 1, 0, 0, 1 over 12, 60. So it's the same thing we are going to use. So there's a pattern, 1 over 3, okay, 1 over 3, so 1 over 3, 1, 0, 0, 1 over 12, 1 over 3, 1, 0, 0, 1 over 12, and we have 60. Okay, so now say times the number either below or above pivot that corresponds with S2. So look at when we are doing S1, we are taking 10. So now it is a turn of 6. So we'll be putting 6 constantly. So this is now going to be 6. So that's how you form this. So see, now we are a bit faster. So this is now going to be 10 minus 6. 1 times 6 is 6. 3 over, this is 6 over 1. So this is 1 over 3. So 3 times 1, that's going to be 3. So this is going to give us 3 times 10, 30 minus 6 all over 3. That's going to give us 24 over 3. 24 over 3. 24 can be 24 over 3. 24 divided by 3. That gives us 8. So that will give us 8. So here we already have 8. Yeah. Okay. So it's as good as saying 10 minus 2, which is 8. That's fine. Then here we have 6 minus 1 times 6 is 6. That gives you 0. So you know that here we already have the 0 already written for us. So you see, we have achieved that 0 here. That was the pattern. This will now become 0 minus 0 times 6 is 0. So that will give you 0. Then this is going to be 1 minus 0 times 6, 0. That's going to be 1. So I have 0 and 1. Let me put that first before I forget it. We have 0 and 1. We have 0 and 1. Okay. Then we will now do this one here to be 0 minus 6 over 2. This is going to be like minus 3. So this is minus 3. So we have minus 3 here. So put our minus 3 here. Then we'll do the last one. So this is going to be 600 minus 6 times 6 is 36. That's 360. 360. You add 40 to it to become 400. That's 240. 240. So we take it down here. So this is going to be 240. All right. Then we have one more lap to go. We'll do C. So just the same way we did that, we did C, X, C, Y, C, S1, C, S2, C, S3, and C, sorry, C solution. So we'll go and look at the old C line and bring everything out there. Minus 100, 115, 00 all through. So that's what we are going to put as our old in the formula. So we have minus 100 minus 115. We have 0, 0, 0, 0. Somebody is asking a question. Let me see what it is. Sorry, S3 is 1 over 2 or 1 over 12. Okay, which of the S3 are we talking about? This one here is 1 over 12. How did we get 1 over 12? This is it here. When we divided 1, this one here, by the pivot, which is 12, got 1 over 12. That is for the master Y column. For the master Y row, this is 1 over 12. So when we are trying to do them here, okay, okay, wow, I get what you are saying now. 1,001 over 12, 60. Okay, so this is 1 over 12. Thank you so much for the correction. So it's here, it's 1 over 12. So we'll do this side again. So this is going to be 6 over 12. So this is going to be 6 over 12. It's same thing as saying 1 over 2 minus 1 over 2. Thank you for that. Minus 1 over 2. Okay, so we'll go and replace it there. It's 1 over 2. You have to be very careful. Profound thanks for that. Minus 1 over 2. Okay, so that's it. We'll now go here. We have indicated all the C's. So we will now say minus, minus, minus. We already know what we are going to use. Minus, minus, and minus. We've done it before. 1 over 3, 1, 0, 0, 1 over 12, 60. 1 over 3, sorry, 1, 0, 0, 1, 0, 0, 1 over 12, and 60. We're going to multiply by what? The value at pivot line, that is, look at this 12. So this one that corresponds with line C is 115. So minus 115. That's going to be our recurring number. Minus 115. Minus 115. Minus 115. Minus 115. Minus 115. Minus 115. All right, so let's look at it now. This is going to give us minus 100. Now, minus times minus is going to give me plus. It's going to give me 115 over 3. 3 times 100 is going to give me minus 300 plus 115 all over 3. So let's do it now. 300, 300, put the minus before it, plus 115, that gives me 185. So it's going to give me minus 185 over 3, minus 185 over 3. Let's leave it that way. Because 185 cannot be divisible by 3. Okay, I keep making this mistake again. Please always watch out. 1 over 2, 1 over 12 can look like 1 over 2. Okay, thank you. So this 185 over 3 cannot be divisible. If I have to divide it by 3, it's going to give me fraction, so I'll leave it that way. So let me just leave it that way. So minus 185 over 3, we'll just write it here. Minus 185 over 3. This will give us minus 115. Minus times minus will give me plus. 1 times 115 will give me 115. If we do it, it's going to give us 0. We already have 0 written there. And this is going to give us 0 minus times minus gives me a plus. 0 times 115, so it's going to give me 0. That gives me 0. I'll write it soon. This is 0 minus minus gives me a plus. 0 times 115 will give me 0. That's 0. I have 2 zeros to write. This is 0 minus minus gives me a plus. Now this is going to give me 115 over 12. Let me go and write it down. 0, 0, 115 over 12. 0, 0, 115 over 12. Then what is going to happen in the next one here? This is going to be 0 minus minus gives me plus. This is going to give me 115. Okay, it's not multiple. Okay, you have to multiply it. 60 times 115. That gives me 6,900. That gives me 6,900. 6,900. So I will go here. 6,900. Okay. Hmm. Something is telling me something here. Now, do you remember this figure 6,900? Let me recall. Let me recall something for you. Before we continue, did you say 6,900 here as contribution? How did that happen? X is 0 and Y is 60. And here, our Y was 60. There was no X in the solution. So Y is 60, X was 0, and your contribution was 6,900. So this table here corresponds to this particular point A in the graph. Unfortunately, we will not be doing point B in the graph. It's possible we might do point B in the graph to get 6,000. It's possible we may not do it. But because we have 6,900, we cannot get 6,000 because 6,900 is an improvement over 6,000. So we will never get this point. If assuming we got 6,000 first and we want to do improvement, we may get 6,900. But now we got 6,900. The next iteration will be the next improvement over 6,900. So we see here, this is our contribution at this point. Y is 60. So that's not the optimal. Now, we said that our objective is to ensure that in your C line, you either have a positive or 0. The moment you have a negative, then there is room for improvement of this contribution. There is room to improve this contribution because we have something that has negative here. This now becomes the pivot column, the new pivot column. Now, it means that X, the family of X, is now in line to be the new king after the old king has reigned. Who is he going to displace? Is he going to displace S1? Is he going to display S2? Is he going to display the old king, which is Y? Let's see. We will need to know which one is going to be the pivot row. How do we get the pivot row? We simply do that thing we did before. 200 over 14 over 3. This is going to give us 240 divided by 8. This is going to give me 60 divided by 1 over 3. So let's do them now in turn. 200 divided by 14 over 3. So let's do that to get pivot row. So we have S1 here, we have 200 divided by 14 over 3. Notice the way I've written it here. I didn't write it like this so that I want to apply something in mathematics here. When you have to change your divide to times, you interchange. This becomes 3 over 14. When you are changing from divide to times, numerator becomes denominator, denominator becomes numerator. So this is going to give you 3 times 200. This is going to give me 600 over 14. So let's see, 600 over 14. Let's see what it's going to give me. 600 divided by 14. That will give me 42.86. 42.86. So I will just come here. Oh, sorry. That is the table again. 42.86. So let me just put my answer here. 42.86, or just say 42.9. 42.9. I can even say 43. Whole numbers. Now we have 240 over 8. 240 over 8. Let's see what it's going to give us. 240 divided by 8. That's going to give me 30. This is 30. And then we have 60 over 1 over 3. So let's do that. Okay, so I would say this is S2. 240 over 8 gives me 30. S3, 60 divided by 1 over 3 is the same thing as saying 60 times 3 over 1. 3 times 6, 18. That's 180. Okay, so I have 180 here. So the one that has the lowest positive result is the pivot column. So it means that S2 is losing its seat for the family of X to take its place. And the new king, all hail the king, is going to be 8. So in the new table, X will now be the master. Y will no longer has master in it. X will now be the master. And this place where 8 was will be 1. And every other thing under, beneath, or above it will be 0. And remember all these numbers here, we are going to use them in our rule. So you are now seeing the pattern now. We have our pivot column and our pivot number. This is our pivot number. How do we get our new master X? Everything in the pivot column will be divided by the pivot number. So we will now draw our table. Second iteration. Third table. Okay, so we have this third table, we have our basic variable. Then we have X, we have Y, S1, S2, S3, and solution quantity. And we said that S1 will not be displaced. S2 is now being displaced by X. As you can see here, S2 will be displaced, then Y and C will remain. S2 will be displaced by X, and X will now be the new master. Then Y has lose this mastership, then this is C. Forgive me, my lines are not straight, my hands are wobbling, but at least we understand what we are doing. So now how do we get our master filled up? I am going to use this color for master. So I'm going to be dividing everything in the pivot table. So I have 8001 1 over 2, 240. So 8001 minus 1 over 2, 240. So this is supposed to be X, Y, S1, S2, S3, so now I'm going to divide by 8, 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 and divide by 8. Here will give me 1, here will give me 0, here will give me 0, here will give me 1 over 8, here will give me 1 over 8, 1 over 2 times 1 over 8. Because when we change this divide to times, this is 8 over 1 becomes 1 over 8. So 1 over 2 times 1 over 8 will give me, this minus already, minus 1 over 16. Then here is 30. So that's what we are going to put down here in the master. So this is going to be 1. This is going to be 0. This is going to be 0. This is going to be 1 over 8. This is going to be 1, okay, minus 1 over 16. Then this is 30. Now, as I said before, this is 1. So everything here is going to give me 0. That's the law. So let me bring this on to this color. This is 1. Everything here is going to be 0. So now let's go back to do our S1 the way we have been doing it before. We have S1X, S1Y, S1, 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 S2, S1, S3, S1, solution. So what is our old S1 in all of these? We go to the immediate last table, which we just finished. 14 over 3, 14 over 3, 0, 1, 0. Let's write that. 14 over 3, 0, 1, 0. Then the next one will be minus 5 over 6 and 200. Minus 5 over 6 and 200. Okay, so the formula says there's going to be a minus, then all of this is the new, so this is going to be 1, 0, 0, 1 over 8 minus 1 over 16 and 30. Then there's going to be a times the number above pivots. If you look at it here, when we had our pivot number, 14 over 3 is the number above pivot. 14 over 3. So 14 over 3 will run common in all of them. So 14 over 3 will be here. All right, so what will this be? This is going to give me 14 over 3 minus 14 over 3. And that gives me 0. There's already a 0 written down here. Then this is going to give me 0 minus 0 times this gives me 0. That's going to give me 0. This is going to give me 1 minus 0 times anything here is 0. 1 minus 0 is 1. So I'll write this 1, 0, 1 here. There's 0, 1 here. Let's come here. This is 0 minus, because minus times plus is minus. This is going to give me 1 times 14 is going to give me 14. 8 times 3 is 24. So 0 minus this is going to give me the same thing. 14 over 24 is minus 14 over 24. To simplify further, it's going to give me minus 7 over 12. Minus 7 over 12. Minus 7 over 12. Then we go to this next one here. This is going to give us minus 5 over 6. Now, minus times minus is going to give me a plus. 1 times 14 will give me 14. 16 times 3 is what I'm going to check now. 16 times 3. 16 times 3. That gives me 48. It's going to be 48. Because you know this is 16, not just 6. So LCM between 6 and 48. 6 times 8 is 48. So 48 will be the LCM here. So my denominator we have 48. 6 into 48 is 8. 6 times 8 is 48, right? So now 8 times 5, 5 times 8 is 40. So this is going to give me minus 40. 48 into 48 is 1. 1 times 14 is going to give me 14. So this is as good as saying minus 40 plus 14. Let's do that. So this is 40 minus 40 plus 14 gives me minus 26 over 48. Minus 26 over 48. You have to divide by 2. This is going to give me minus 13 all over 24. Minus 13 over 24. Minus 13 over 24. Okay, then you come here and you have 200 minus times plus is minus 3 times 14, 30 times 14, or I'll do it this way. 3 cancel here 1, 3 cancel 30 is 10, right? So 10 times 14, that's how it's going to be. 10 times 14 is 140. So 200 minus 140, that will give me 60. So that's going to give me 60. So I'm going to write 60 here. Okay, then we will do our y. We are done with S1. So we now have y, x, y, 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 S1, y, S2, y, S3, and y solution. Okay, so go to the old y and bring the values. 1 over 3, 1, 0, 0, 1 over 12, 60. 1 over 3, 1, 0, 0, 1 over 12, 60. Right? You know there's going to be a minus. We know what is going to be there. All of these figures here. 1, 0, 0, 1 over 8, 1 over 16, and 30. 1, 0, 0, 1 over 8, minus 1 over 16. Then we have 30. We know there's going to be a multiplication. So let's go and find out number that is in the y region, but just above or below the pivot. Because y is going to be 1 over 3. 1 over 3. So 1/3. Okay, so sometimes you need to know something here. There's a trick I will show you now. Because x is the king, what we have for x, the first number we have for x, that is what is going to be all through. If you notice, when y was the king, the number we have for y was what was all through. The number we have for y was all through. The number of what we have in y was used all through. So that's the same thing as since x is the king, the number we have for x is what we'll be using all through. Just have to watch the video several times so that you can remember. All right, so let's do this. Now, this is 1/3 minus 1/3. That gives me 0. There's already 0 there. This is going to give me 1 minus 0. That will give me 1. This will give me 0 minus 0. That will give me 0. So let me write this 1 and 0 before I continue. 1, then 0. Then let's go further. This is going to give me 0 minus 1/8 times 3 is 24. So this gives me minus 1/24. Let's write that minus 1/24. Okay, so the next one is this is going to give me 1/12. Minus minus gives me a plus. 1 times 1 is 1. 16 times 3. Did we do that? 16 times 3 gives us 48. 16 times 3 gives us 48. So this is going to give us 48. Now the LCM is 48. 12, 24, 36, 48. So 4 times. 4 times 1, 4. 48 here is 1. 1 times 1 is 1. So that gives me 5/48. So write like that, 5/48. You cannot break it down further. 5/48. Okay. So the next one is 60. Now minus 3 divided by 30 is going to give me 10. 60 minus 10, that gives me 50. So I'm going to write 50 here. All right, so we now go to the next one, which is our contribution. So this is C, C, Y, C S1, C S2, C S3, C solution. So let's go down and bring the old C minus 185 over 3, 0, 0, 0. Let's write it down first before my head will burst. Minus 185 over 3, 0, 0, 0. Minus 185 over 3, 0, 0, 0. I remember that this last one is 6,900. So let's go down and get 115 over 12. 115 over 12. So, and I told us that we're now going to write all of these common things. 1, 0, 0, 1 over 8, 1 minus 1 over 16, 30. 1, 0, 0, 1 over 8, 1 over 16, 30. Because, and I told you that since x is the king, whatever we have here is what we are going to be putting all through. We saw that trick there. So this is going to be minus 185 over 3 minus 185 over 3 times minus 185 over 3 times minus 185 over 3. Careful of the signs. Times minus 185 over 3. Okay, so let's take them one after the other. This will give me minus 185 over 3 minus will give me plus 185 over 3, which is 0. We have 0 already there. This will give me 0 minus, okay, minus become plus. 0 times anything is 0. That's 0. This will give me 0 minus times minus is plus. 0 times anything is 0. This is going to give me 0. Before I go on, let's write the two zeros. So we have there 0 and 0. So what do we have here? So this is minus times minus is going to give me plus. 1 times 185 will give me 185. 3 times 8 is going to give me 24. So that was give me 185 over 24. Let's write that 185 over 24. 185 over 24. Then let's see here. This is going to give me 115 all over 12. This is getting interesting. Within this bracket, we have minus times minus, which is already plus. So it means that minus times minus is plus, plus times minus is going to give me minus. All right, that is settled. 1 times 185 is going to give me 185. 16 times 3 is going to give me 48. So 48 is going to be the denominator. 8 times, 12, 24, 36, 44 places. 12 into 48 is 4. 115 times 4. 115 times 4. That gives me 460. 460 minus 48 into 48 1. 1 into 185 is 185. So that gives me 460 minus 185. Let's see. 460 minus 185. That will give me 275 over 48. 275 over 48. Let's leave it that way. 275 over 48. 275 over 48. Okay, and let's do the last one. I know what the last one is going to be. Let's just confirm. We have 6,900 because minus minus will give me plus. 10, 3 cancel 30 is 10. 10 times 185 will give me 1850. Now let's add them together. 6,900 plus 1850. That will give you 8,750. 8,750. So let's write it down here. 8,750. Now, when you finish writing, you check the value of C. Can you find any negative values? You cannot. So, as negative values are not there, optimality has been obtained. So, I'll write down here, I'll just write after the second iteration, which is the third table, there was no negative contribution. Thus, optimality has been reached. All right, optimality has been reached. Now let's interpret this table. Now I want us to look at similar table which we did here when we get optimality. X is 30 and Y is 50. Your X happens to be 30. So your X here, this is your X, which is 30, and your Y, which is 50. So you've got your optimal solution here. And we said our maximum contribution is 8,750. You can see it here. Maximum contribution here is 8,750. In this same table, we can also see that when we found the slack variable, we found out that S1 is 60. which is the slack. So S1 here, which is 60, which is the slack variable. So this is your slack. This is your production of X, production of Y, and your maximum contribution. Now let's do something else again. Can we do 185 divided by 24? What do we have? 7.71. So I'll say 7 point, sorry, what did I get there? 7.70 or 7.7, 7.71. Then can we do 275 divided by 48? We have 5.73. 5.73. Can you remember where we saw this figure? Let's go to our shadow price. We have for shadow price for what again? We are trying to do shadow price for M2. M2. This is the 7.7 here, which is this. Because it's M2 that gives you. So this is supposed to be M1, machine 1. This is going to be machine 2 and machine 3. So your M2 is 7.70 something because of approximation error. And look at the other shadow price. We got 5.73, which is the same thing we did here. So these are your shadow prices here. These are your shadow prices. These are your slack variable. This one that is having S, that is unused, is slack variable. This one are the solution that you are going to get. This is your contribution. So all the positive figures we have here, so it means that there is no slack variable. You cannot be saying slack variable, and you cannot be saying shadow price for this. So shadow price for machine M2 is this. Shadow price for M3 is this. And this is the slack for S, unused. So that is it. You have used this table to answer the whole question that we did last week. We just answered it using Simplex method. This solution, you've seen your slack variable, your optimal solution, your optimal contribution, and your shadow prices. Question is, will you be required to do this Simplex method, all these iteration in the exam? Are we required to do that? Well, for me to answer that question, we look at the syllabus. What the syllabus tells us about Simplex method. Let me get the syllabus for you so that you will see what the syllabus say about Simplex method. Just a moment. So let's see what the syllabus say about Simplex method. Okay, so we'll need to join me. Let's get the syllabus down. I think I don't have it here offhand. So let's get the syllabus downloaded. Let's look for Simplex method. Let's see what the syllabus say about simplex method so that we will know whether we are going to be using, we are going to be doing all of this, or what is it about the simplex method that your examiner wants you to know. So for a moment, so now let's look for the simplex method. Now, they said the simplex method is limited to formulation of initial table or tableau and interpretation of the final tableau. So you see here, in your decision making, you are going to apply linear programming involving simultaneous equations, which we did before, graphic techniques, and simplex method. We've done all that. But the note here is the simplex method is limited to formulation of initial table, which is formulation of this initial table. So you'll be given everything. You are the one to do all of this objective function, do all of these ones here, and you will form the initial table. You may not, you might decide not to. They might ask you what is a pivot column, what is a pivot row. They might not ask you, but forming this initial table might be the first part. And they said here, interpretation of the final table. So it means that they might ask you this your A part, then your B part. They might just get this thought table for you and ask you to interpret. And how do we interpret this? We say the optimal solution is to produce X 30, Y 50, have our maximum contribution to be 8,750, the slack variable, which is S1, machine 1 was unused, slack variable of 60, and we have machine 2 and machine 3 giving us the optimal solution, and their shadow price are all these ones here. So that is what they want you to know. But you see, there is no way you could have known this if we have not taken the steps to arrive at this. So that's why these steps are also in your materials, which you can decide to know that, but know that in the exam you may not be required to do it, all those simple steps. Now they said, note, computation and interpretation of shadow prices are required. So you see here, all the things we did in the last class are all required. Everything we did in the last class. In today's class, the part I want you to really know is forming the initial table and then interpreting the final solution. So that's how the simplex method is being done. So we are going to get our summary now. We now say, let me use this. Summary of results. One, the simplex method gives the same, 'answer' 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 as the graphical method. Two, the final table of the simplex method summarizes one, the optimal quantity to be produced. Two, the optimal solution or contribution. Let's say contribution, optimal contribution, optimal contribution achieved. Three, the slack variable of the underutilized underutilized um, underutilized item. Four, the shadow price or prices of the fully utilized items. So it covers everything. And the third thing here is that when forming the simplex initial table, all all functions, e.g., objective function and constraints, must be arranged in the standard form, standard matrix form. So when we say standard matrix form, so those ones that are X, all the X will be in one line, Y and all that. So the ones that doesn't have any of the slack variable, so I will say it here, the function that has some slack variable and missing others must be arranged in the same standard form. So it means that the one that has S1 but no S2 and S3, you have to put S2 and S3, but you put 0 in front of them. Okay. Number 4, the pivot column. Okay, before the pivot column, the contribution, the contribution is the last line in the table, and they are set to have negative values for the variables and zeros for the slack and solution. And the fifth one is as long as the C line has a negative figure, optimality is not reached. And a new table, or I say iteration, must be made. Sixth one, to form a new table, the pivot column must be found first. The PV, okay, the PC, which is a pivot column, is the column that has the value of C with the greatest negative number. Okay. Number 7, the basic variable, or let's say the variable at the head of the pivot column will displace one of the basic variables. This displacement is determined when we find the pivot row. Number 8, the solution divided by each, okay, let me write it divided. The solution divided by each element in the pivot column is done. The one that gives the lowest positive. Remember, the other one for pivot column is highest negative. Pivot column, highest negative. For pivot row is lowest positive, is the pivot column. That column will be displaced. Number 9, the pivot number is the intersection of the pivot column and the pivot row. This is very important in forming the new table. Also, the numbers above pivot number, okay, above or below, above, above, stroke, below pivot number are also important. Number 10, the master line or row is entered first by dividing all elements in the pivot row by the pivot number. Then number 11, the other row are found using the formula old corresponding okay, old corresponding position minus new, say master corresponding position times number above or below pivot number. This is position, all right? 12. Test if optimality is reached by checking if the new C line has positive or zero values. So if you look at these 12 things I've just said, this is your key in learning how to do this simplex method. But like I said, you are limited to forming the initial table and interpreting the final solution. So I won't stress you that much with it, but all I will tell you is for you to look at, to read this material which I will send. Okay, this is your study pack. Read your study pack because it shows how this can be done. You can walk with them through and see the examples that they did here. Try your hands with it to see if you can understand. So this is just one example here in this material, so you can follow the train to see how this was done and compare. So you can see here, this is the interpretation that they want you to do. They might just bring the final table and just bring all of this for you and put every other thing, and they ask you to interpret. Okay, so you can look at, okay, there's no question here on it, just one example which you can follow through. But I have in my own material, I have examples, example 1 and 2, which you can do with the um, graphical method, the simplex method. You can try them, use the simplex method to do them. So I've done the example here. So you can also follow the train of thought of how this is being done. This is another example here, and you can use that to test your knowledge. So this example 3, that we use simplest method. You can also use the graphical method. We did it there. Use the graphical method to test the simplex method. You can also use the simplex method to test your graphical method. So these are some of the things you stand to gain. So thank you so much for coming to class. And this video is going to be sent to you when it is done so that you can enhance your learning. If you are still finding it difficult to grasp this topic, please watch the video several times because this is a topic that is not fully tested. So you don't want to go into the exam hall and they now bring it out and you are found wanting. More especially, the example in the study pack, please make sure you do it. Because if ICANN is going to bring an example, an exam question, they might take a question from the study pack or from past question or from maybe ACCA. So if you have that, you can look at similar topic and find a way to do that. So thank you so much for making this class a lively one. I'm going to see you again in our next class when a different topic will be discussed. Another exciting topic. You don't want to miss that.